shadowing, but it's still correctly identified the duck overall. Now in this example, there's a lot of background noise, a lot of yellow in the baby and the tile, and we are correctly able to identify our duck, yellow duck. Since we defined a rubber duck to be yellow, the blue and red rubber ducks in this image are correctly ignored because they fall outside of our definition of a rubber duck. But this algorithm does a good job at filtering out the yellow noise in the background of this picture and identifying this rubber duck here. In this image, we have a real duck and a rubber duck. Once again, the rubber duck is correctly identified and the real duck is correctly ignored. The color scheme of the real duck falls outside of the parameters of our rubber duck here because it isn't a true yellow. It's kind of a pale brownish color. Its beak is a little bit pink, but if it had very bright colors, it would have been identified as a rubber duck. Here we have another example of a correctly identified side view of a rubber duck. And here's yet another one, frontal view. The cheek here is a little bit orangey, and that's included as part of the beak. So there are some slight problems, once again, because of shadowing, but that duck is still correctly identified. Here we have 4 ducks on the beach. The larger 2 are correctly identified, but the smaller 2 are not. And that's because this image is kind of low resolution, as you can see. So it's a smaller image. And the 2 smaller rubber ducks, their eye and beak segments are too small to be considered, so they are filtered out as noise. This could be improved upon by either allowing for smaller eye and beak parameters, but that would allow for additional noise and additional false positives as well. But if we used a ratio of the image size to the beak size, for example, if we used that a beak, had to be larger than 1/100th of the image, for example, then that would allow for images that are lower resolution, like this one, to still detect rubber ducks that aren't too small. In a higher resolution image, this would have been detected. For example, our first image, the rubber ducks were not too much bigger than this, and if these rubber ducks had been in that image, they would have been detected because that was much higher resolution. So we could either fix this, like I said, by reducing our minimums or by making a ratio for our minimums to allow for lower resolution. In this image, we have a rubber duck that is not identified at all. And when we look at the yellow blobs here, we see that most of its body is not detected, and it has a lot of holes in it, and it's not really the shape of a rubber duck. If we look at the orange-red image, most of the body is identified as orange because of this orange wing here. So because of that, these two cannot really be correctly paired, and this is not defined as a body. So this orange color has made it so that we cannot find this duck. It falls outside of our color parameter. To accommodate this duck, we could change our color parameters, or we could use machine learning to teach our program to define parameters for itself, and it would be able to incorporate this duck into the existing conditions. Here we have another duck that is not detected for color reasons. The yellow body was detected very well, but here we have the image of the red or orange blobs, and if you look at the beak, it's very small and very fragmented, and it's not able to see the beak as a whole. It just sees a couple splotches of it. And because of that, the beak was not identified, so this duck was seen with an eye and a body, but it was not seen with a beak, so it was missing one of the key segments and could not be identified as a whole object. Once again, this could be fixed by changing our parameters for color or adding a machine learning capability to teach the color parameters to our algorithm. In this next image here, we have those same 4 ducks that occurred on the beach. And in this image, since it's zoomed in a little bit further, we are able to detect the blob bodies of the 2 smaller ducks. However, only this middle one here is correctly identified. And when we wonder why this is happening, if we look at the yellow blob detection of the image, we see that only sections of the large duck are seen here, and there's a lot of holes in our smaller duck, and the eyes here are not holes within this image. They're just a section missing out of it, so it's not really seen as having an eye. So those 2 are thrown out because they're blotchy and they don't have an eye, and the same with the big one. And the reason for this blotchiness and the inability to find the body is because of the shadowing here on the front. These pictures were taken in the afternoon, and the shadowing has changed our color scheme. This could be enhanced by either changing our color parameters or doing some color pre-processing on the image. One of the IEEE papers that I researched involved image pre-processing, in which a filter was run over the image, and it would enhance the colors until they mapped to a color spectrum that had the appropriate hue, intensity, and saturation. So that could increase the saturation and the brightness and allow us to detect those ducks. Now, we also see problems when ducks overlap, as in this example. We find one big duck that encompasses all 4 ducks, but really there are 3 little ducks on a big duck boat. And if you look at the bob detection, they're all kind of combined here. This could be fixed by using ratios once again for a ratio of beak to body. And when we find different beaks here, we would find four unique beaks within this body, and we would be able to match the large beak with the large body, and we would know that there are 3 other beaks inside, so that would give us a hint to look further into this image. And we could use some stricter edge detection within this image to isolate the 3 smaller ducks and identify them all. So a way that we could improve the algorithm would be to use ratio of beak to body, and when too many beaks are detected, use strict edge detection within the duck to isolate the ducks and pull apart overlapping ducks. However, in the algorithm as it currently is, it does not work that way, so we only identified one of the 4 ducks in this example. And in our last example here, we have a duck that's overlapping with a bright yellow puddle. Now, because it has that slight overlap in the tail here, the image sees this whole blob as part of the duck. If we applied that ratio once again of beak to body, we would see that there was a problem here because the beak is so small compared to this giant body that takes up the whole screen. So we could apply stricter edge detection and be able to separate out this body and correctly identify the duck. However, in this example, the duck is not identified. Instead, it says there's one duck that takes up the whole screen, as you can see by this red line. So in conclusion, I tested 58 test cases, and I found my algorithm to be 97.81% accurate. And we can improve this algorithm by using ratios, machine learning, pre-processing for color, and stricter edge detection. But however, we were able to show a very good accuracy